Hello, Chemist Corner. Today I want to talk to you about the mole. It's a very important number in chemistry, but that's all it is. It's a number. 6.0221 times 10 to the 23rd. Sometimes also referred to as Avogadro's number. We do a lot of mole calculations, but all a mole is simply that number, in the same way that a dozen is 12, a number. Avogadro's number, or the mole, is simply 6.02 times 10 to the 23rd. It's just a really, really, really large number. How large? Well, I want to give you a couple of examples. If we take just an ordinary sugar cube, this is about 4.5 cubic centimeters. Let's round it up to 5 centimeters. If I take 1 mole of sugar cubes, how much is that equal to? Well, I did the math ahead of time, and 1 mole of sugar cubes works out to be 3.01 times 10 to the 21 liters, or 3.01 times 10 to the 9th cubic kilometers. 3 billion cubic kilometers. How much is that? That is 2 times all the water on Earth. If we had 1 mole of these. Okay, well, what about mass? If I take my 1 kilogram mass and say, okay, I want 1 mole of these masses. 1 mole of these masses would be 6.02 times 10 to the 23rd kilograms. So 6.02 times 10 to the 23rd kilograms, how does that compare to the Earth? Well, the mass of the Earth is 6 times 10 to the 24th kilograms. So 10 moles of this mass would be equivalent to the entire Earth. Well, that's because this is a fairly large object. Why do we use the mole in chemistry? Well, what we're trying to describe is the masses of elements, the masses of atoms, the masses of molecules. Here are a couple of examples. If we take 1 mole of water, that's how much it is. 1 mole of water, 18 milliliters. That is 6.02 times 10 to the 23rd molecules of water right there. That tells you that a molecule of water is quite small. If we take a metal, here is 1 mole of iron. It's about 55.8 grams of iron filings. That is 1 mole. That is 6.02 times 10 to the 23rd atoms of iron. Some compounds are a little larger. If I take sodium carbonate, 1 mole of sodium carbonate, 106 grams, that's how much it is. Weighed these out ahead of time. 106 grams, 6.02 times 10 to the 23rd formula units of sodium carbonate. That tells you that a molecule or an atom is very, very tiny. Very tiny. If I've got 6.02 times 10 to the 24th kilograms, that's the entire Earth. But if I have 6.02 times 10 to the 23rd atoms of iron, it's only this much. So how do chemists use the mole in their calculations? Well, very simply. We pull the number for the atomic mass units off the periodic table. So if I say 1 mole of iron, that is equal to 55.8 grams of iron atoms. We now have an equality that we can use to do some calculations. If I want 1 mole of water, that's going to be equal to 18.0 grams of H2O. And once again, if I've got an equality, I can develop a unitary rate and use that in my calculations.